meets you again. I call myself Mr. U.S. Patil, working as Assistant Professor at Sharad Institute of Technology, College of Engineering, Edra, Chalkaji, District Kolhapur, Maharashtra. In this video, we'll see the hardware in CAD. We'll see contents, that introduction, basic hardware structure of digital computer, central processing unit that we call CPU, types of memory, operator input devices, and plotters and other output devices. This plotters is nothing but that is one of outer devices. Come to the introduction. The hardware component for computer aided design are available in various variety of sizes, configurations, and capabilities as well. Hence, it is possible to select a CAD system that meets the particular computational and graphics requirements of the user firm. Engineering firms that are not involved in a production would choose a system excuse, exclusively for drafting and design related functions. Manufacturing firms would choose a system to be part of a company wide CAD CAM system. A complete CAD CAM system consists of a hardware and software components. The hardware includes a digital computer and its peripherals. A digital computer is a machine that can solve problems for people by carrying out instructions given to it. Its speed and storage capacity have facilitated to rapid growth of CAD CAM industry. In order to understand CAD CAM, it is essential to be familiar with the concept and technology of the digital computer. Yes, so the modern digital computer is an electronic machine that can be perform mathematically and logical calculation and data processing functions in accordance with the predetermined program of instructions. The computer itself is referred to as hardware, whereas the various programs are referred to as software. Here, there are some there are some three basic hardware components of a general purpose digital computer that we can see here. There is first one is a central processing unit, that is CPU. Second is one memory, and third one is input output section. As the relationship of these three components we can see here, the central processing unit is often considered to consist of two sections: a control unit and an arithmetic logic unit that you called ALU. The control unit coordinates the operations of all the other components. It controls the input and output information between the computer and the outside world through the computer and outside world through the input output section. The synchronizes the transfer of signal between the various sections of the computer and commands the other sections in the performance of their functions. The arithmetic logic unit carries out the arithmetic and logic manipulations of data. It adds, subtracts, multiplies, divides, and compares numbers according to the programmed instruction. Yes. The memory of the computer is the storage unit. The data stored in this section are arranged in the form of word which can be conveniently transferred to the ALU, or input output section for processing. Finally, the input output provides the means for the computer to communicate with the external world. This communication is accomplished through peripheral equipment such as readers, printers, and process interface devices, etc. The computer may also be connected to the external storage units also. For example, you can say tapes, disks, etc. through the input output section of the computer. Here, CPU, computer or central processing unit, it regulates the operation of all system components and performs arithmetic and logical operations on the data. To accomplish these functions, the CPU consists two operating units, that is called, we say already, that is control unit and algorithm arithmetic logic unit. The control unit coordinates the various operations specified by program instructions. These operations includes receiving data which enter the computer and deciding how and when the data should be processed. The computer unit directs the operation of the arithmetic logic unit. It sends the data to the ALU and tells the ALU what function to perform on the data and where to store the results. The capacity of the control unit to accomplish these operations is provided by a set of instructions called an executive program, which is stored in a memory. The arithmetic and logic unit program or this arithmetic and logic unit performs operations such as additional, subtraction, and comparisons. These operations are carried out on the data in a binary form. The logic section can also be used to alter the sequence in which instructions are executed when certain conditions are indicated and to perform other functions such as editing and masking data for arithmetic operations. Both control unit and arithmetic logic unit performs their functions by utilizing registers. Computer registers are small memory devices that can be receive, hold, and transfer data. Each register consists of binary cells to hold bits and data. Right? See, the arrangement of these registers constitutes several functional area of the CPU. A representative configuration is, we can see here in this figure, to accomplish a given sequence of programmed instructions. The functions of these registers units are, so this is program counter. The program counter holds the location or addresses of the next instruction. An instruction word contains two parts, an operator and an operand, or a reference to an operand. The operator defines the types of arithmetic or logic operations to be carried out. We can say additional, compression, etc. The operand usually specifies the data on which the operation is to be performed. The CPU sequences the instructions to be performed by fetching words from memory according to the content of the program counter. After each word is obtained, counter, the program counter is incremented to go on to next instruction word, that is memory address registration. The location of data contained in the computer's memory unit must be identified for an instruction, and this is function of the memory address register. This unit is used to hold address of data held in memory. A computer may have more than single memory address register also. Now this is what instruction register. The instruction register is used to hold the instruction for decoding. Decoding refers to the interpretation of the coded instruction word so that the desired operation is carried out by the CPU. Now this is accumulator. Accumulator is a temporary storage register used during an arithmetic or logical operation. For example, you can say in addition two numbers, the accumulator would be used to store the first number while the second number was fetched. The second number would then be added the first. The sum still contained in the accumulator. See, the second number would then be added to the first. The sum of them, sum still contained in the accumulator would then be operated on or transferred to the temporary storage according to the next instruction in the program. Next, status register. Status registers are used to indicate the internal conditions of CPU. A status register is a 1-bit register. We can say 1-bit register, often we can say flag. We called 1-bit register, we can say a flag. The flags or 1-bit register are used to identify such conditions as logical decision outcomes, overflows, and interrupt conditions. Next, this is arithmetic logic unit, ALU, that is arithmetic logic unit, ALU. The ALU provides the circuitry required to perform the various calculations and manipulations of data. The unit, that is ALU unit, has two inputs for data, inputs for defining the function to be performed, data outputs, and status output used to set the status registers. The arithmetic logic unit can be simple adder. The arithmetic logic unit is a simple adder, or it's a circuitry can be more complex for performing other calculations such as multiplication and division. So ALU is with simpler circuits are capable of being programmed to perform these more complicated operations, but more computing time is required. But time would be required more. The more complex arithmetic logic units are faster, but these units are more costly. So next, the types of memory, we can say the memory is that part of a computer wherein programs and data are stored. The present day computer system the often exists a greater number of hierarchical hierarchical level of computer memory. There are two basic categories. You can see here when selecting a memory chip for use in a digital computer, a designer normally has a wide selection from which to choose. Some features that are commonly examined during selection of specific memory chip are, you can say, capacity and organization, timing characteristics, power consumption, and loading, bus loading, and physical dimensions and packaging, cost, reliability, availability. The capacity of memory chip is generally measured in terms of number of bits and bytes it contains, whatever it contains. As most chips contains more than a few thousand bits, the memory capacity is expressed in kilobytes. We can say that KB, or megabyte, we can say MB, or gigabyte, we can say that GB. The timing characteristics are AC characteristics. Power consumptions and bus loading are also known as DC characteristics. The memory, which is integral to the computer, is called main or primary memory. The main memory is divided into two or three categories. Sorry, we can say this main data storage. We can say this is main memory, that is primary memory. Designates storage area that are physically a part of computer and connected directly to the CPU. It includes the working registers and memory devices closely configured to the CPU. It can be divided in three main categories. First one is main data storage. Second one, we can say uh, control storage. And third one is a local storage. The main data storage, we can say primary storage. The main memory or primary storage are terms which designate storage areas that are physically a part of the computer and connected directly to the CPU. It includes the working registers and memory devices closely configured to the CPU. Primary storage can be divided in three main categories, as I said, that these three, and so we can say one by one that main data storage. What is that? The main data storage, such as magnetic core or solid state memory, this storage is characterized by its close proximity to the CPU, fast access rate, relatively low storage capacity, and very high cost compared to other form of memory. And we can say second one, control storage, is which commonly contains micro programs that assist the CPU circuitry in performing its functions. The logic storage is the high speed working registers used in arithmetic and logical operations. So some are the semiconductor memories are also used for storing information. There are various types. We can say that read only memory, we call that ROM, programmable ROM, random access memory, erasable PROM, erasable programmable read only memory, and electrically erasable and PROM, that is EEPROM, and flash memory. So this is next one is the auxiliary memory, that is we can say a second storage. The programs and data files not generally kept in a primary storage but are stored on large capacity auxiliary devices and loaded into main memory as required. Main storage is very expensive and has rather limited capacity. There are again two basic types secondary storage, that is auxiliary memory, that is sequential access storage, and direct access storage. If we say the sequential access storage, a sequential access storage unit is distinguished by the fact that to read one particular record in the file, all records preceding it must also be read. Sequential. Or if you say a direct access storage, in which or with this storage method, individual records can be located and read immediately without reading any other record. So this is, we can say, a direct access storage. So next we see the inputs of here, input and outputs. So everyone, we know that inputs, that everyone is go through these inputs. First one, we can say this is a keyboard. But what input? The user of CAD CAM systems spends a lot of time sitting at a workstation, communication and interaction with the computer to develop a particular engineering design. A number of input devices are available. These devices are used to input the two possible types of information, that is text and graphics. Text input devices are the arithmetic or character oriented, that is keyboards. There are three classes of graphical input devices: locating devices, digitizers, and image input devices. So we can say here that one kind of is keyboard. You can see here keyboard, that is a keyboard, that is input. The keyboard is the most basic input medium for all computers. The layout of the key on the keyboard generally consists of a traditional typewriter keys together with some special keys, right? Some special keys which are used for controlling execution of the program or the screen display. So now here this is what scroll keys we can say, or you can say cursor movement keys. These are the numerical keys, or you can numerical keys. These are the function keys, and this is we can say, actually here is colored one, that we can say modified keys, and this is escape key. So this is alphanumerical keys. This is what a keyboard looks like. And this one is, you everyone knows that this is mouse. The mouse is the pointing device which has been gaining importance with the advent of microprocessor and the pull down mm, menus associated with application software. The mouse operates on the three principles, that is mechanical, optical, and you can say optomechanical. Optomechanical, optical and mechanical combined, that is optomechanical. And next you can say light pen. You can see here light pen. The light pen resembles the fountain pen in the method of holding, but it works on the principle of light rather than ink, right? The lighten is a pointing or picking a device that enables the user to select a displayed graphics items on the screen by directly touching its surface in the vicinity of the item, right? So this is called light pen. And this is joystick. These we called a joystick. This is also joystick, and this is also a gaming board, we can say, that is joystick. The vertical and horizontal displacement of a joystick produce a corresponding movements of the cursor on the screen. The extreme position of these displacements corresponds to the four corner of the screen. A joystick may be equipped with a rotating knob on the top, which can be used to enter a third axis values, thus making the joystick a three-dimensional input devices. Three-dimensional input device, we can say. Now, this is what digitizer. Digitizer is the most widely used input medium by a CAD designer. It is used for converting the physical locations into coordinate values so that accurate transfer of data can be achieved. And data glove, we can see here data glove. Data glove records three-dimensional hand and figure position. We can see here, and therefore the hand and the finger motions. In the data gloves, each finger joint has a short length of fiber optic cable attached. At one end of the fiber optic cable is small light emitting diode, that is LED. At the another end is a photo transistor. At the other end is phototransistor. A small portion of the cable is roughened. The small portion of the cable is roughed. They may have a rough. When the cable is flexed by the movement of the finger, some of the light is lost. Hence, less light is received by the phototransistors. The intensity of the received light is interpreted as the position of the finger joint. In addition, a separator system senses and gross position of the glove. This is, we can see how it works. Now another is that trackball. The trackball is similar in a principle to a joystick, as we see here joystick, but it allows more precise fingertip control. The ball rotates freely within its mount. The trackball is used in radar and flight control systems. The trackball is used to navigate the screen display cursor as well. So now this is thumb wheels. Uh, thumb wheels are usually required to control the screen cursor. One for is horizontal position and uh, the other for its vertical position. Each position is indicated on the screen by the cross hair. Thumb wheels are usually mounted on the keyboards. Yes. So this is what inputs are devices. Here some are outputs. As we know, the outputs of the graphic output devices are divided into soft and hard devices. The former refers to graphics display or terminals which only display information on the screen. Hard output devices refer to hard copy printers and plotters that can provide permanent copies of displayed information, isn't it? So this is a kind of, these are the outputs. Uh, so monitor, printer, speaker, projector, headphones, all are the outputs. So this is what require the hardware of CAD. So we'll see. Thank you. We'll see in the next video soon. Thank you. Thank you very much.